Alright, this is a continuation of yesterday's lesson. Oh, sorry, 2 days ago. Sorry, yesterday I was very caught up with a lot of stuff. Sorry. Okay. Remember we were doing this last question on kinematics. Okay, we actually discussed all this, and then I asked you to think whether the answer for this part 4 was correct. Okay, so very good. Many of you pointed out to me that I shouldn't just find the time, I should find the distance. Okay, so I purposely asked you whether my answer is correct or not because in the markers report for this particular paper, right, the students actually, a lot of them, they left out this. That means they happily do so much, right? Then they found the time and then they thought that that was the answer. Okay, so that is not the final answer. They want to find the distance traveled. So you take the speed times the time. Okay, so that will be your answer in meters. Okay, and also I missed out question number 9. This particular question, I've only gone through part 1. I forgot to go through part 2, so sorry about that. We have found the coordinates in exact form of B and C already. Okay, then now the question wants us to find the area of the shaded region, which is here. Okay, so as per normal, you see whether you can put a man here and then you walk along here, the ground. So the heaven and the earth throughout the whole journey of the man is the same, right? Okay, so you integrate from 0 all the way to pi over 2. That's what I've done here. Take the heaven, which is this equation, minus the earth, which is the red one, and that is the equation of the normal, which you have found in the previous part. Alright, now whenever you do such questions, my advice from what I see you do in prelims, right, is to open up the bracket. Okay, it's advisable to open up the bracket first, then you integrate. Okay, and remember, when you see x over 3, right, it's actually the same as 1/3 x, which means when I differentiate the argument, it's just 1/3. So you divide by 1/3, and then you can easily press calculator to get 6. Alright, do not make any mistake here. Then sub in, I get this, right? Okay, I have to be very careful here. This is sine, so when I sub in 0, sine 0 will be 0. But if it's cos, cosine, right, then it's not 0. You have to be very careful, okay? Or if there's an exponential function here like e to the power x, you got to be very careful. E to the power x is not 0, okay? It's 1. Okay, so you should get the answer as 3.98. And don't forget your unit square. Alright, now we'll move on to the MGS paper 1 that I've given you 2 days ago. Okay. Now this was what you were given for question number 1. Sketch the graph of ln square root 2x minus 1. Now, to sketch this graph, you have to understand that ln functions, okay, the argument, whatever argument is here, right, it has to be greater than 0. So in this particular question, they are very nice to us. They already specified very clearly that, sorry, I'm looking for my pen. Never mind. Okay, that x greater than half. Okay, but actually we can simplify this further by writing this whole thing as 2x minus 1 whole thing power half, and then using the power law, you throw this to the front here. Alright, so that it becomes like simpler. But having done this, still this 2x minus 1 argument must be greater than 0. Okay, because you cannot ln a negative number, so 2x minus 1, you make it greater than 0, you will end up with x greater than half, which was actually what they're trying to tell you. Now, if x is greater than half, that means the graph can only be on this side. Alright, meaning to say that this x equals to half vertical line is the asymptote. Alright, And nothing, no graph should be drawn on the left hand side because x is always greater than half. Alright, it cannot even be equals to half because you cannot have ln 0. Correct? You cannot have ln 0 here. So it's greater than half. Meaning to say the graph will look like that. Do not touch the asymptote. It's going to go like a fountain, you know, the water. It's going to go like that. Okay? So you label this as y equals to ln square root 2x minus 1. So that's done already for the graph. But you notice that this curve actually cuts the x-axis at some value. So it must have some x value, right? Meaning the y value is 0. So you sub y equals 0 and you will, using the laws of logarithms, be able to get x equals to 1. Then you label 1 here. And it makes sense, it makes perfect sense. This is half, this is 1. Yeah, it makes sense, right? Okay. And the next part of the question requires us to insert in the sketch the additional graph required to illustrate how a graphical solution. Okay, it may sound very difficult, but it's nothing more than whatever you've done in e-maths. Okay, so if you remember in e-maths, whatever you have drawn already, right? Whatever you have drawn already, if you want to find a graphical solution, right? For another equation that they give you, in this case is this one, then you, is this one, then you must somehow try to get back this. Okay, so bear in mind, y equals, right here, okay, y equals to ln 2x minus 1. I throw the half down here, okay, because as I always say, have the n in mind and then you work backwards. Okay, now you take a look, that means I must try to get this to come out so that my curve equation can come out. Okay, now look at this. Do you see 2x minus 1? Somehow, yes, there's a 2x here equals to this plus 1, right? So if I minus 1 both sides, I will get 2x minus 1. Alright, that's half the better one already. I have this part here. If I can ln both sides, I'll get ln 2x minus 1. Am I right? So you ln both sides. And rightly so, because when you ln, you will be able to throw this fella down. Okay? Now, a serious mistake would be to ln from the first step. If you ln from the first step, right, this 1 is trapped inside the ln already, so it cannot come out. So you have to make sure you get the argument first, okay? The argument first, then you ln. Then everything will fall in place. Now you need a half here, right? That's why you see I took out a half. I simplify this thing to help me in my manipulation. I times half both sides, I'll get this. And isn't this my this? Okay? And isn't this the equation of the curve that you have drawn? Okay? So this is your curve. This is your line. So you must now sketch this fella. Y equals 3 minus 2x. Okay, so you see, it's the same as your elementary mathematics. Okay, y equals to 3 minus 2x. So y equals to 3 minus 2x is the same as y equals to minus 2x plus 3. So the y-intercept is 3, gradient is minus 2. Okay, and I want to find out, you see we always must label the intercept. So I know that I must have an x value. I set y equals to 0. Okay, I will be able to get my x value as 1.5. Okay, so the line, right, please use a ruler. Line will be this line. This line will be this line, okay? Then you label y equals to 3 minus 2x. That's all. Okay, now, does the question require us to do anything else? No, the question only says insert in your sketch the additional to solve this. So that's all. If you know your syllabus, right, requires you to explain whatever, right? Okay, if they require you to explain, you still need to show this working, okay? A typical question will be like that. They will say explain. Down here, right? Down here, they will say explain how. Explain how a graphical solution may be obtained. Then you will say, oh, you do this, you see, you do this working, okay? This mathematical working is required, is essential. Then you say, insert. There you see, it's like rephrasing this, or you can say sketch this. Insert the graph of y equals to 3 minus 2x into the above graph or axis, okay? And the solution, right, is the intersection of the two graphs. That's all. That means what you're trying to tell the examiner, right? They ask you to explain how a graphical solution to this may be obtained. You just say, oh, I have already drawn this, now I draw this, right? Then the point where they intersect, that is my graphical solution. That's all. Alright? So that is if you have to explain, but in this case, no, right? Okay, now we are going to the next question. And the next question is typical O-level standard question. Okay, they ask you to find dy dx, alright? So I'm going to differentiate this using the product rule first. Then this one is individually on its own, so it's just one, right? Now, differentiate this is this times this, so it's function plus function, so it's product rule. I differentiate this, I get this one don't touch. Now this one don't touch, differentiate this is 1 over whatever I see here. Differentiate x is just 1, alright? This will earn you 1 mark already. Now you move on. This one you cannot do anything, leave it. This one you can simplify, and you must simplify to get this. Alright. Now after you have done this, leave it. That's all. It's the simplest form already because there's nothing else to simplify. Alright. That's all for the first part. Now they say hence find this. Now you must always be very careful. From your lessons in the prelim exam, right, you must understand that you see carefully what is here and you see carefully what is here, okay? So this is what you want, and this can be found here. So if I differentiate this, I get this, right? It means that if I integrate this, I will get this, okay? So that is your first step. You do that first. Here, integrate this, you get this. Alright. Then, what I have highlighted in red, right, is exactly what they want. Okay, so we don't want a 6. Now, I'm going to, before that, integrate this, right? Can you put this constant here? Okay, just put. I know you say down here don't have, but please put, it can be 0. This C can be 0. Okay, now what I need to do is, step by step, I integrate this, and I must have a plus C because plus C1 because I'm integrating this. Alright, so C, then C1. Okay, then now I divide throughout by 6. Okay, because I want to get this. If you want, you can throw all this to the right hand side, then later then you divide by 6 is the same thing. Now when I divide by 6 here, no more 6. I divide by 6 here, you press calculator, 3 over 2 divided by 6, you get 1/4. Okay, so remember, don't make this any mistake here. Now when you divide C1 by 6, you get another constant, so I change it to C2. Alright, divide by 6, half. Divide by 6, another constant, so I call it C3. Okay, now next, only want this on the left hand side, throw everything to the right, that's what you get. Alright, so that's all for this particular question. You must score for all such questions, because everybody in Singapore would find it, manageable. They can do, you can do, fine. They can do, you cannot do, gone case. Okay, the equation of this is this, where P is a constant. Now P is a constant, P is a constant. There are two P's here. Now find the range of values of P for which the curve lies entirely above the x-axis. Now for such questions, where you know there is a happy or sad face, in this case, must it be a happy or sad face for it to lie entirely above? Can it lie entirely above like that? Cannot, right? Because this curve goes on forever, then you will cut already. So this is not the correct curve is not a sad face, it has to be a happy face, and because it lies entirely above, so it's like that. Okay, which means that this is greater than the line, because this equation of the line is y equals 0, so it has to be like that. Okay, this will give you marks already. Alright, so in the exam you have to write greater than, you cannot write equal to 0. Okay, I'll explain more when we go through the question. So the for this condition, right, your coefficient of x squared must be positive, happy face. That's number one. Don't miss out this. A lot of people will miss out. And then, although it's always greater than 0, this is less than 0 because it doesn't cut. Okay, so these are the two conditions. You work it out, you will get this. Alright, but then you see, this is this. Okay, correct? But then, right, you have to combine this with this. So these two have to be combined together, and that's where you get this final answer. Alright? So don't leave out this part here. Oh, I found my green pen. Okay, yeah, I was looking for my green pen. Okay, now, in the case where p equals to 3, show that the line is a tangent. Now, when it's a tangent, very straightforward. Alright? Okay, I sub in p equals 3 into the equation. Then this is a tangent. I sub them, and this is equal sign. You work it out. Okay, be very careful here. Be very careful here. What am I doing? I'm trying to equate this equation, okay, to this. Alright, and I get this quadratic equation. But because the line is a tangent, right? So b squared minus 4ac equals to 0. Correct? Alright, but in this case, because they ask us to show that this is tangent to the curve, I cannot immediately say b squared minus 4ac equals 0. I got to work it out. That means I'm now working out from basic, what is b squared minus 4ac, and it turns out that it's 0. Okay, so since the discriminant, which is b squared minus 4ac, right, is equal to 0, therefore this one is a tangent to the curve. Okay, so this is a showing question. Alright, now I hope you understand me. If you don't understand, please PM me. Okay, now the next one, number 4, is on this. Okay, now if you remember, there's a, okay, not really similar to your prelim, but almost there okay. The curve, this is such that where this one is a constant, and that the normal to the curve at this passes through this point. Okay, so how do we do this particular question? As I mentioned, you just anyhow draw a curve to give yourself a better visual. So the curve is y equal mx, right? And you know that the normal to the curve, okay, before you can draw normal, you must draw the tangent. Alright, always start with the tangent, then you won't make mistake. Okay, then the normal, let's say I draw a dotted line to make it more obvious that it's a different line. So we have a normal here, then this is your point A, which is 0, 3. Okay, this point, okay, of course, if you think about it, this is 0, 3, 4, 4 cannot be here, 4, 4 cannot be there. It actually is I draw wrongly, but never mind. Because this one is just for my own visual. What you call that? Circles, then you cannot do this, okay? Circles, you cannot do this. Coordinate geometry, then you cannot do this. You must draw more accurately. But this one is okay, okay? This one I just want to have a feel of where's the, what's the normal, what's the tangent, okay? Now, what do they want us to find? They want us to find the value of k. Now, where is k and what is k? K is f prime x. F prime x means this equation, right? You go and differentiate it, okay? Which means that the m is f prime x of this. Okay, and the k is hidden here. Alright, now this question, how do you think we can find k? Should we integrate? Okay, if you integrate, you will have still, you can go to try, okay? You still have k inside because k originally was there. You integrate this equation, k will still be there. And then you have a plus c. So you have two unknowns. So even you sub this in, it's not constructive. Alright? Two unknowns, you need two equations. But you only can get one equation. Alright? So that may not be a very good start lah. But you can do that and that will gain you some points. So what you need to do is to recognize, you see, that's why this picture is so powerful. From here and here, you see got 2 points, you can find gradient of this normal, right? Okay, and once you found gradient of this normal is 1/4, you immediately know that the gradient of this is -4. Then you know already lah. This teacher draw wrongly, it should be the point should be somewhere here. Okay, but never mind lah. This one is just to help you visualize a bit lah. Okay, so at 0, 3, now you see, now you know why. Now because I know that the gradient, this is gradient, right? And this is gradient, right? This is gradient of tangent. This is gradient of tangent. So at this particular point, the gradient is this slope. I sub in, I can get k equal -4. So that's the strategy to use. Meaning, yeah, we can blindly do, but you see, I am breaking it down for you how to think more efficiently. Okay, next, they ask you to find this. You see, that's why just now I say if you have integrated this, you have gotten some marks. Now we integrate this. You will get this because we already know that k is 4. Then you can get the answer already. Okay, integrate this is this, integrate this is this. Okay, so remember when you integrate, my advice really to you, the stakes are high. Don't make careless mistakes, okay? Differentiate, you get cos. Differentiate, you get minus sign. Differentiate this, you get secant square. And then when you integrate, you get this. So write this down. You can write on your formula sheet or whatever. Make sure no mistake here, okay? Because you'll be referring to this. So integrate sign, there should be a minus, right? Throw this minus over there. That's why it's like that. Integrate, okay, the doggy, don't bother about the doggy. Just copy as it is. Integrate cos is sign, like that. Okay, then you must have a plus c. Remember, plus c, plus c, plus c must be there. Okay, then how do you find the c? Because this curve lies on this, this point lies on this curve, right? So you sub in and then you can get the answer already. That's all, okay? So that's all. You go to number 6. Okay, number 6, again, is a calculus question. Now you are told that y equals to ex over 2x for x greater than 0. Then you will ask, why must x be greater than 0? It can be less than 0, what? Yeah, we agree it cannot be equal to 0. But why did the question say x greater than 0? Okay, so this one is, they want it to be greater than 0 lah. It can be less than 0 also can, but they want it to be greater than 0, then we just follow them, okay? That means they define for us as x greater than 0. Alright, now determine the range of values for which y is a decreasing function. Now we know already. Now we know that this is something very important. Okay, we cannot later we cannot happy say, oh, x not equal to 0, x can be less than 0, x can be greater than 0. Cannot. You know why? Because they already told us that x greater than 0. So these are not valid, you know what I mean? I mean, this is a fact, this is a fact, but they already told us this is the condition they want. So we work within this condition. Alright? Now determine a range of values of x for which this one is a decreasing function. You know that decreasing function is okay, later I go through dy. Decrease less than 0, makes sense, right? Okay, now but before we can do that, we have of course have to differentiate this Okay, so how do I differentiate? Very simple. Product rule is like that one. Quotient rule is like that. This one, the template is minus then over square. Differentiate this is just EX times 1, right? So no need to write actually. This one don't touch. Okay, done already. Now, this one don't touch. Differentiate this, you get 2. Okay, now, after this, I recommend that you use a pencil. You have E2x here. Okay, separated by a minus, right? You have E2x here, E2x here, very good. You have a 2 here, 2 here, very good. That means these two are the common factors. Take out 2EX, okay? It should be a very fast process and not so many steps just to simplify. Okay, so you use pencil, okay? Don't use pen, don't use pen, okay? After that, the denominator is 4 and x squared, right? That's all. Okay, now we move on. Now we are ready. Now we are ready to say that, okay, this one dy dx is less than 0 for decreasing function. Oh, sorry, I didn't simplify, my fault. Actually, it happens in your prelim also. Many of you didn't simplify something like that. I think it's 2 over 2, something like that. Okay, so always remember to simplify and then you move on. Now, for decreasing function, this is less than 0. Correct? Okay, but we say like that, since EX greater than 0. Okay, since EX greater than 0, this one is always greater than 0, right? So this is always positive lah. X square, okay, this one, you should follow this. Everybody follow me. If you had done this like me, right, don't do that. You must say for x greater than 0 because this is a condition given to us. Can you write that? You can either write here or write here. So you say for x greater than 0. Okay, safer is to write here, then it covers all your subsequent working. For x greater than 0, this one greater than 0, that means 2x squared greater than 0. That means this whole thing is positive. So the only way for this to be negative, okay, the only way for this to be negative, which is this one, let me write here, is clearer. This is positive already, this is positive. So this must be negative for this to be less than 0, right? That's why it's x minus 1 less than 0. That's why this is the answer, lor. Okay? Can, but, like that, right? You see how important this is? Many of you will just leave the answer here. I suspect many of you just leave your answer here. But because of this condition, that's why this condition is very important, and that's why I spoke so much about it just now. Since this one greater than 0, right? So final answer is this. Because this answer means 1. Go all the way forever until infinity, minus infinity. No, no, because at 1, at 0, it stops here. It's actually greater. It's actually greater. So this is the overlapping part, and that's your answer. Alright, so I hope you are clear about this. Now, the second one may sound and may seem very difficult, but actually it's a very easy question. You need to master the technique of translating English to mathematical language. So the variables x and y are such that when x equals to 2, okay, that means everything happens only when x equals to 2, okay? When x equals to 3, 4, 5, 10, whatever, it's a different kind of story. Alright? So, y is decreasing at the rate of this one. So, y is decreasing at the rate of per second. This means dy over dt equals to increasing, right? So, it's a positive. Okay? Actually, I think I've written here. Yeah. See, I've written here like that. Okay? Find the rate of change of x in terms. Okay, what do they want from us here? They want the rate of change of x, meaning dx dt lah. But the answer, they only want it when x equals to 2, and your answer must be in terms of e. So that's the whole thing that they want from you. So how do we do it? You see, there is dy dt we know already. What else do we know? We know x equals to 2. Then we want to find dx dt. How to find? How to find when x equals to 2? Yeah, so you don't think that this is the an isolated question, The relationship between x and y actually was here. Okay, at the first part. So what you need to do is, you know you want to find the dx dt, right? You want to find this one. So you have no choice but to do the ninja split. Okay, ninja split, dx dt, you split it up, split it up like that. Okay, then you need a dummy. No choice but to be dy dy. Why? Because you already know this. Okay, that's 0.25. Alright, and this fella dx dy, you can do things like that. Okay, you come here and then you do the dy dx. Hey, take note, this one and this one, they are inverse, reciprocal. Okay, so what I do is, never mind, I don't care, I go and find dy dx. For the previous part I already know. I've already worked out already. So I sub in and I get this. Okay, I leave it in E. Why? Because final answer they want in terms of E. So do not 3SF or whatever here. Then you won't be able to get the answer. Okay. Then now I work out here. Like that. I throw inside. Okay. Take note. This dy dx is E squared over 8. So dx dy, which is a flip side, right, is 8 over E squared. Then I do this. Can I 3SF? Cannot. Cannot 3SF. Okay, cannot 3SF. It must be exact because they want in terms of E. Okay, so that's all for this particular question. Next 6 part 3, sorry. Given further that the variable z is this. Okay, show that when x equals to 2, z is decreasing at k e power 4 times the rate of y, where k is a constant to be determined. It sounds very difficult also, but actually it's not difficult. Things that sound difficult seem difficult, actually they're not difficult. You take a look at this. Okay, then you take a look at x equals to z is, you must show that z is increasing at this state. So what does this mean? It means dz over dt, okay, is equals to, is decreasing at these times, where k is a constant to be determined, right? That means you must find k. Later you must find k. Okay? And the dz dt is k e to the power 4 times the rate of this. That means dy dt lah. Okay, so that is the whole story. Now let's take a look. Firstly, I write dz dt. Why like that? Because they say what? Show that this dz dt, that means I must find dz dt. I must find dz dt. I must find that this dz dt is equals to ke whatever times dy dt. Okay? So never mind. I split up first. dz, ninja split, dz dt. So what do I put here? Based on whatever I have here, it has to be dy. You see, dz dy there. I can dz dy here. So what do I do now? I know dy dt. I don't need to find. Correct? Well, then you ask me, no need to find dy dt. No need. You see, they only want you to show that dz dt, okay, is some number. I found the number already now. Times what? Times this fella. Okay? So what you need to do now is to find dz dy here. So you differentiate this with respect to y, you will get 3y squared, and that's dz dy, isn't it? And because all these things happen when x equals to 2. It doesn't happen at x equals to 5, 10, 20, minus 2, whatever. It happens only at x equals to 2. So you sub x equals to 2 inside, and you will find that, there is no x here. Okay? So you have to see, no x. No x. But the previous part, actually all these questions are linked. I hope you understand. The previous part, right, you can actually find when x equals to 2, what is y? And once you know what y is, you throw the y here, then you win already. So throw the y here, then you win already, okay? So it's all linked to part 1, okay? So we are now going to continue, and once you sub in here, you will get this, right? So this is your y. You sub this back here, okay? Sub this back here, you will get this, okay? You will get this, and then once you have this, you throw this back here. Alright, so that is the whole thing. Okay, now maybe those who are sharper, okay, you check through and then you see whether there is any mistake or not. If there's any mistake, you let me know, okay? You read the question carefully. Okay, you read the question carefully and then you read this and then you see whether any mistake or not. Any mistake, you let me know, okay? Now you must be able to spot mistakes. So that's part of the training. Okay, now we go to the next one, number 7. Given that this is this. Now, this question is very simple. You know why? They already tell you what to substitute. Now, in the prelim exam, there is a question that is something like that. Okay, this wasn't given, and because this wasn't given, many of you see stars already, don't know how to work things out. Now, it's very simple. Okay, you always try to break it down to the simplest form. So some of you go and break it down to let x equal x plus p equal x plus 1. In the prelim exam, I'm saying sorry, p equal x plus 3. Do not do that. It's very complicated. Okay, so what do? You break all this up. Break it up. You see, this can be broken down into this and this. This can be broken down into this and this. Even if it's a minus, right, you just put it as multiplication, because the minus simply means divide by 8. So it's like 1/8 of the p. Alright, so you break it out like that, then you see what is the simplest form, not simplest like basic cell, which is this. So you just let so because this question is guiding you, so very simple, okay, then that's all. You see, they're guiding you to solve part 2. Part 2, you just apply it and then you can solve the equation already. That's all. This question is very simple. Now, perhaps this part, then maybe you have some problem. Explain why this is no real root if k greater than 0. So if k greater than 0, that is the condition. Alright. Now, we take a look at this, and then it's very complicated if you were to try and do it like that, right? Then has no roots. What's the implication of has no roots? So what you do is, again, you apply this strategy of simplifying these indices, all these indices inside this equation, right, into a very simple equation which consists of p square, p, and a number k. Okay, so it has become a quadratic equation already. And when you have a quadratic equation, you can check whether got roots or no roots using your discriminant. Alright, now of course the key point here is you need to do this substitution. If you don't do this substitution, right, it will be very hard for you to so-called break things up and then determine whether it's got real roots or not. Okay, and then there's another condition here if k greater than 0. Alright, now after you've done this, okay, what do you think is the next step? Well, you have to, no choice but to find the discriminant, or the b square minus 4ac, which is d square minus 4. Then. So this is your discriminant, right? Okay, this, remember, we have done this in class so many times with that, so many examples. You start from this. This is the starting point. You start from here. Then you slowly work out from here. This k is here, right? And k greater than 2. Okay, then now you times minus 2 both sides. This one times minus 2 is this one times minus 2. And don't forget your inequality sign must flip because you multiply by a negative number. Alright, then you plus 49 both sides. You will get a negative number. But this is your b squared minus 4ac, you see? You are trying to get this b squared minus 4ac, which is the discriminant. So the discriminant less than 0, this one has no real roots. Okay? Yeah. So can you see that for this particular question, we have used this information. and we have transformed this fella into this fella that we can easily study because it's a quadratic equation. Yeah, so mathematics question in the O level is very, very what we call the short and sweet. Okay lah, may not be very short. I see this question so long. Okay, what I mean is